Hello, I am Sharat Jain, Assistant Professor in Department of Electronics and Communication Engineering in Institute of Engineering and Science, IPS Academy, Indore. The topic of today's lecture is Superposition Theorem. In the previous classes, in the first unit of the BEEE, we learned about the components, linearity, unilateral, bilateral, then Ohm's law, KVL, KCL. Now we are going to start a superposition theorem. Here we will learn what is a superposition theorem, what is its utility, what are its limitations, how its statement, and how we can use a superposition theorem in order to calculate the response of a given network or circuit. So I must say superposition theorem is a very important concept in network analysis. This theorem is particularly used when a given network have more than one energy sources. With the help of superposition theorem, we can calculate a voltage across a component or a current flowing through any branch or element. With the superposition theorem, we calculate the voltage drop or current with one source acting at a time while replacing other sources, or we can say making the other sources inoperative. Means when we consider one source at a time, all the sources are replaced by their internal resistance. In this way we get the response of a given circuit. Once we know all the responses due to all the sources acting alone, will superimpose all these responses on the top of each other, means we'll add these responses algebraically in order to find out the final response or the final output that we wanted to calculate for a given circuit. So when should we use the superposition theorem? We should use the superposition theorem when the circuit is not too complex. Means circuit is simple, circuit is having two or more energy sources. The energy sources may be in form of voltage source or a current source or a combination of both. So the statement of the superposition theorem is: in any linear network containing two or more sources, the response, means voltage or current, in any element is equal to the algebraic sum of the responses caused by individual sources acting alone while the other sources are inoperative. What does it mean? It means whenever we apply the superposition theorem for a given network, what we do, we calculate the response by considering the one source at a time while the other sources are made inoperative. The process of making other sources to be inoperative is done by replacing these sources with their internal resistance. In the next slide we'll see what are the internal resistance of these energy sources and how we replace them. So the important thing is that as we know, we apply the superposition theorem in the network when we have more energy sources, two or more than two energy sources. So these energy sources may be in form of voltage source or current source. The important thing is that we must consider these voltage sources as a ideal voltage source and the other current sources as ideal currents. Why we are saying other? Because we are considering one voltage source at a time and will consider the other, if present, voltage sources as a ideal voltage source. Similarly, if we are considering current source at a time, then the present other current sources will be treated as ideal current source. As we know, the internal resistance of an ideal voltage source is 0. Therefore, the all the voltage sources will be replaced by a resistance 0, means all the voltage source will be replaced by short circuit. Similarly, you know the internal resistance of an ideal current source is infinite. Therefore, all the current source when replaced will be replaced by an infinite resistance, means all the current source will be replaced by an open circuit. Here you can see in the figure, this voltage source when replaced by its internal resistance, it will be replaced by an short circuit, because the internal resistance of a voltage source is always 0. When this current source is replaced by its internal resistance, it will be replaced by an open circuit, because the internal resistance of the current source is infinite. Okay. The important thing is that we can apply this theorem to a linear circuit only. What is linear circuit? We can say that the circuit whose property or whose parameter does not change with the change in voltage or current is called linear circuit. Or we can say, for a linear circuit, this particular equation is satisfied, is applicable. F of x1 plus x2 is equal to f of x1 plus f of x2. The second important thing of the superposition theorem is that the circuit in which we are applying superposition theorem, it must have the component which is bilateral. The meaning of bilateral is that the current must be flow in both directions without changing the property of that element. We know the best example of the bilateral element is the resistor. The current in the resistor can flow in both directions without having the change of property of resistor. While the opposite of bilateral is the unilateral. Example is diode, because the diode conducts only in one direction. The diode conducts current only in one direction, while in the other direction either it doesn't conduct, or the property of the diode changes while conducting the current in the reverse direction. So there are two most important properties of the circuit it must have while applying the superposition theorem, is that it must be a linear circuit and the components used in the circuit must be bilateral. So there are certain steps that must be followed while applying the superposition theorem for a given network in order to calculate the response. The first step is that out of the many energy sources, we will select only one energy source at a time, and all the energy sources will be replaced by their internal resistance. As I told earlier, all the voltage source will be replaced by zero internal resistance, means all the voltage source will be replaced by short circuit, while all the current source will be replaced by infinite resistance, means all the current source will be replaced by an open circuit. With first step completed, we'll follow the second step. In the second step, what we do, we will calculate the response whatever is asked in the problem, considering the only one energy source at a time. So in this way we can calculate the voltage or current, voltage drop or a branch current, with proper voltage polarities and current directions. In the third step, what we will do, we'll take the second one energy sources and we'll repeat the step 1 and step 2. So we'll do these steps 1, 2 for all the sources individually. In the step 4, it must be 4. In the step 4, all the responses will be added algebraically in order to calculate the final response of the circuit. Basically, when we apply superposition theorem, we must consider all the sources to be an ideal. Means all the voltage source will be considered as an ideal voltage source and all the current source will be considered as ideal current source. What happens when we consider this ideal voltage source and ideal current source? When the voltage source are considered to be ideal, their internal resistance will be 0, when the when the current source will be considered as an ideal, their internal resistance will be infinity. One important thing is, one more important thing is about the superposition theorem is that we can apply this theorem in order to calculate the voltage and current, but in the same manner we cannot apply this superposition theorem to calculate the power. As we know, power equation is not linear, and the superposition theorem can be applied only to a linear circuit. So now we are starting the application of superposition theorem for a particular network. We are taking one example. In this example, find IL for the given circuit shown in figure using superposition theorem. हमको for this figure shown, we have to calculate this one current that is flowing into the 30 ohm resistor. As you can see, there are two sources, 50 volt source and 20 volt voltage sources are acting simultaneously. With presence of these two sources, we have to find out the current flowing through the 30 ohm resistor. We are not interested right now to calculate the current in 10 ohm and 20 ohm as it is not asked in the problem. So we'll find out only the current through the 30 ohm resistor while taking both sources individually. So what we'll do in the step 1, we'll calculate the current flowing through the 30 ohm resistor with 50 volt source. In the step 2, we'll calculate the current through 30 ohm resistor with the 20 volt source, and step 3 will calculate the total current, that is total response. So in the step 1, current through the 30 ohm resistor due to the 50 volt source is IL dash. Let us see how it is calculated. So this is the scene. We have considered only 50 volt source and replaced the 20 volt source with short circuit. Now we have to calculate this current. This current is the branch current. In order to calculate this branch current, we must know the total current supplied by the circuit, and in order to calculate the total current supplied by the circuit, we must be knowing the total resistance offered by the circuit. We can see this 30 ohm and this 20 ohm resistor are in parallel, and this parallel combination is in series with the 10 ohm. So the total equivalent resistance of the circuit is 10 plus the parallel combination of 20 plus 30, so it will give you 22 ohm total equivalent resistance. Now we know the total equivalent resistance, we know the total voltage, so we can calculate the current flowing in the circuit. So the total current I is equal to V upon R. V is the 50, R is the 22. In that manner we calculated 2.27 ampere current that is flowing out of the positive terminal of this 50 volt source. So this is the total current, not the current flowing into the 30 ohm resistor. We are interested to calculate the current at 30 ohm resistor, so we'll apply current division rule. So according to current division rule, the current flowing through 30 ohm resistor is 2.27, that is the total current, into 20 upon 20 plus 30, because there are two resistors in parallel, 20 and 30 ohm. It will give you 0.909 ampere. So we can say this current 0.909 ampere current is flowing through this 30 ohm resistor due to 50 volt source. Now in the step 2, what we'll calculate, we'll take 20 volt source in picture and we'll short circuit the 50 volt source. So the current flowing through this 30 ohm resistor is now IL dash. So in order to calculate again the branch current, we should know what is the total current supplied by this source. In order to calculate the total current supplied by this source, we must be knowing the total equivalent resistance of the circuit. As we can see from the circuit, this 10 ohm and 30 ohm resistor are in parallel, and the parallel combination of both is in series with 20 ohm resistor. So equivalent resistance of the circuit is now 10 and 30 parallel combination plus 20 is in series, so it will give you 27.5 ohm total resistance. Now we are in position to calculate the total current supplied by this source. So current supplied by this source is V upon R, V is the 20 and R is the 27.5. It will give you 0.73 ampere. This 0.73 ampere current will flow out of this positive terminal of the 20 volt source. But we are interested to know this branch current. So this branch current can be calculated using current division rule. So according to the current division rule, the current flowing in the 30 ohm resistor is 0.73 is the total current, and the 10 upon 10 plus 30, because two branches are in parallel, 10 and 10, 10 and 30. So it will give you 0.181 ampere. So this 1.181 ampere is the current which is flowing in the 30 ohm branch due to 20 volt source. So we have covered both voltage source, 50 volt as well as 20 volts. We know the current flowing through 30 ohm resistor due to both sources. Now in the step 3 we'll calculate the total current that is flowing out in the 30 ohm resistor. You know, the current flowing in the 30 ohm resistor due to 50 volt source is from top to bottom. Also, the current flowing in the 30 ohm resistor due to 20 volt source is also from top to bottom. I mean to say, the direction of current that is flowing in the 30 ohm resistor due to both source when acting separately is same. That's why the total current will be added. So we can say that IL is equal to IL dash plus IL dash dash. So it will give you 0.909 plus 0.181. This is the current when the 50 volt source is in force, and this is the current when the 20 volt voltage source is in force. So the answer is 1.09 ampere. It will flow in the 30 ohm resistor when both sources are working simultaneously. Clear? So now we move on the second problem. In the second problem, what is saying? Use the superposition theorem to calculate the current in branch PQ of the circuit shown in figure. Means I have to calculate the current in the PQ branch for the given circuit in which there are two voltage sources, 4.2 volt and the 3.5 volt source is there. Okay, so what we'll do in the step 1, we'll consider the 4.2 volt and will replace 3.5 volt by a short circuit. Now in order to calculate the current in the branch PQ, means the branch current, we will have to find out the total current supplied by the circuit. For that we need to calculate the total resistance, equivalent resistance of the circuit. As we can see here, this two resistance 3 ohm and 2 ohm are in parallel, and the combination of 3 ohm and 2 ohm parallel resistance is in series with 2 ohm and 1 ohm. So I can say the total equivalent resistance of the circuit is now 2 plus 3 and 2 parallel combination plus 1. So it will give you 4.2 ohm. So the total current supplied by the circuit is now I is equal to V upon R. V is the 4.2, R is also 4.2, so it will give you 1 ampere current. So we can say the total current supplied by this source is 1 ampere, but we have to calculate the current in 3 ohm resistor, that is a branch current, so we'll have to use current division rule. So when we apply the current division rule, it will give you the current flowing through the PQ branch. It will be 1 into 2 upon 2 upon 3. Why we took 2 and 2 upon 3? Because there are two parallel branches of 2 ohm and 3 ohms. It will give you 0.4 ampere. Now in the step 2, we'll take 3.5 volt source and will replace the 4.2 volt source by a short circuit. Again we are interested to find out the current in the 3 ohm resistor. So this is the branch current. In order to calculate the branch current, we'll need to find the total current supplied by the circuit, and in order to find out the total current supplied by the circuit, we must be knowing the total resistance offered by the circuit. As we can see here, 2 ohm and 3 ohm are in parallel, and 1 ohm is in this 2 ohm and 1 ohm are in series, and this series combination of 2 ohm and 1 ohm means 3 ohm. 3 ohm and 3 ohm are in parallel, and again 2 ohm is in series. So total equivalent resistance of the circuit is 1 plus 2, 1 plus 2, these are in series, and both series combination is in parallel with 3 ohm, and the whole combination is in series with 2 ohm. Okay, So this is 1 plus 2 means this 1 and this 2 is in parallel with this 3 ohm. Okay, so the whole combination is in series with 2 ohm. So total resistance of the circuit is now 3.5 ohm. So we can calculate the total current supplied by the circuit is I is equal to, again, voltage is 3.5, current resistance is 3.5, so the 1 ampere current will be supplied by this battery in this direction. Now in order to calculate this current, will have to apply current division rule. So when using the current division rule, the current through this branch 3 ohm is equal to 1 into 3 upon 3 plus 3, because two branches are in parallel, 3 ohms and 3 ohms. So it will give you 0.5 ampere. 0.5 ampere is the current that is flowing into the 3 ohm branch. But see, the direction of the current is from bottom to top for this particular arrangement of this resistor, while in the previous case when 4.2 volts source was acting, the direction of the current flowing in the 3 ohm resistor was from top to bottom, means the direction of current are opposite to each other for both sources. So the net current will be the 0.4 minus 0.5. I have reversed the direction of the current for the second source. So answer is minus 0.1 ampere. So the magnitude is 0.1 ampere that is flowing into the circuit in the 3 ohm into the 3 ohm branch, and the minus sign indicates that the current is flowing from Q to P, not from the P to Q, Q to P, because Q to P current is more than the current from P to Q. So I can say this source is dominating in the circuit. Okay, so let us move on the next example. In the next example, what we have to do, determine the current I in the branch AB using superposition theorem. This is the branch AB. We have to find out the current flowing through this 2 ohm branch. How are the some differences in the previous circuit is that here the combination of current source and voltage source are used. So same procedure in step 1, will consider this 2 ampere source and will replace this 10 volt source by a short circuit or zero resistance. So this is the scene when replacing the 10 volt source by a short circuit. We can see we have to find out the current in this AB branch. So these 2 and 5 ohm are in parallel, so we can redraw this circuit. This 2 ohm and this is 2 and 5 ohm in parallel. It will give you 1.43 ohm parallel resistance. What we have to do, we have to find out the current in 2 ohm resistor. So by current division rule, we will calculate the total current is the 2 ampere current will come from here up to here and will divide into this branch and this branch. We are interested to calculate the current in 2 ohm branch. That's why we'll calculate, will put here 1 ohm is the opposite resistance upon 1 plus 3.343. So it will give you 0.45 ampere current. This is the current, this is flowing through AB branch when the 2 ampere source is working alone, and the direction is from A to B. Now in the step 2, we'll take the 10 volt source and we'll replace this 2 ampere source by its internal resistance. Since the internal resistance of an ideal current source is infinite, that's why we replace it by an open circuit. Now the scene is that here this open circuit doesn't mean no more. Now this 1 and 2 ohm are in series, and this series combination is in parallel with the 5 ohm, and the whole combination is in series with 2 ohm. So now the total equivalent resistance of the circuit is 3.875 ohm. So the total current will be V upon R. V is the 10 volt and the total resistance is 3.875. It will give you 2.58 ampere current. So it will flow from the positive terminal of the 10 volt battery, but we have to calculate this current flowing in the AB branch. Current through the AB branch can be calculated by using the current division rule. So from the current division rule, this current will come up to this point, B point, from where it will divide into this branch and this branch. So the current division rule will give you 2.5 into 5 into 2.5, because the current is dividing into two branches, 2 ohm branches and the 5 ohm branches. Sorry, this branch is 2 and 1 3 ohm branch and 5 ohm branch. So this is 5 upon 3 plus 5. So it will give you 1.613 ampere. So we have calculated both currents. When the current when the 2 ampere source was working, and the current when the 10 volt source was working. Here we can see that the direction of the current flowing into the AB branch is opposite to each other. When the 2 ampere source current was working, the direction of the current in the AB branch was from A to B, while when the 10 voltage source is in force, the direction of the current flowing in this branch, AB branch, is from B to A. So the total current will be 0.45 minus 1.613. I have reversed the direction of the current, which is more, since the 1.613 magnitude is more than the 0.45. So the net current is the minus 1.163. So magnitude is 1.163 ampere current, and direction indicates that the current is flowing from B to A, as 10 volt source is dominating in the circuit over the 2 ampere source. So this is the answer. Okay, so let us move to the next question. In the next question, what we have to do, using superposition theorem, determine the current in 5 ohm resistor. We have to calculate the current in the 5 ohm resistor. This is the 5 ohm resistor. There are two sources. In the step 1, what we'll do, we'll try to find out the current due to the 30 volt source in the 5 ohm resistor. So what we'll do, this voltage source will be replaced by a short circuit. That we replace this source by a short circuit. Now these two are in series, and 5 and 20 means 25 ohm resistor is in parallel with the 4 ohm. So the picture is like that. 30 volt source is there, 2 ohm resistor. So the total resistance is series combination of 2 ohm and 3.45 ohm. So we can say the total resistance, equivalent resistance, is 2 plus 3.45. This is 2, this is 3.45. So we can calculate the total current. Total current is total voltage upon total resistance. Total voltage is 30 volt and total resistance is 5.45 ohm. So the total current is 5.5 ampere. But we are interested to calculate the current in 5 ohm, and the 5 ohm current can be calculated by using the current division rules. So as per current division rule, the current in the 5 ohm resistor is 5.5 is the total current, 4 and 425. Since the current is dividing among the 4 and 25 resistor, that's why we took 4 and 25 here. It will give you 0.76 ampere. In the next step, what we'll do, we'll take the another source, that is second source, and we replace the first source by its internal resistance. Now taking this 25 volt source, so in order to calculate the current, first we'll have to find out the total equivalent resistance. So the total equivalent resistance, in order to find out the total equivalent resistance, we can see that these two resistors are in parallel and this is in series with this combination. The total resistance is 1.25. So equivalent resistance will be 4 plus 1.85 is equal to 5.85. From this total equivalent resistance, we can find out the total current. Total current will be the 4.27 ampere. Now we are interested to find the current through this branch, 5 ohm resistor. So using the current division rule, this current is 4.27 and 2.2 plus 25. It will give you 0.3163 ampere. As we can see, both currents are in opposite direction. That's why the net current will be 0.75 minus 0.3163. It will give you 0.4437 ampere, and the direction of the current is same as that of the direction of the IL dash, that is the direction of the current due to the first source that you have considered. So this is the answer. In this manner we have completed the superposition theorem. We learned in this lecture what is the superposition theorem, how it is applied, what are the steps that I have to follow in order to calculate the response of a circuit while applying the superposition theorem, what are its limitations, and some examples when we apply how we apply the superposition theorem. Thank you.